Hey guys, welcome back to another math lesson with Heikyo Math and Science. This video will be about decimals and fractions and about how to convert between the two. So by the end of the lesson, we should all be able to convert decimals to fractions, be able to convert fractions to decimals, and finally be able to understand the symbol to indicate recurring decimals. Alright, so let's pause the video here and take a minute to write these down in our exercise books. Alright, so the first thing we need to know for this lesson is our first success criteria, and that is how to convert decimals to fractions. And to do this, we're going to use our knowledge of place value to express the decimals as a fraction, and then simplify the fraction wherever possible. So if we recap on our knowledge of place value, this was the tenths place and that was the hundredths place. So that means we'll have a total of 25 hundredths. And 25 hundredths in a fraction is written like this, 25 over 100 or 25 hundredths. And we'll simplify that by its highest common factor, which is 25. Both the top and the bottom can be divided by 25, and that will give you value of 1 over 4. Alright, so using our knowledge of place values, we're going to give this a shot ourselves. So this one we have the tenths, hundredths, and the thousandths. So that will be 239 thousandths, and that is simply written as 239 over 1000 or 239 thousandths. And that doesn't look like it can be simplified any further because the top one is a prime number, so that is what 0.239 or 239 thousandths would look as a fraction. Alright, moving on to the next one, we have 10.35 or 10 and 35 hundredths. If you look here, that's a tenths and that's a hundredths. Anything before the decimal point is going to be the big number in a fraction. So this will be a mixed number fraction. So we have 10 and 35 hundredths. And now we can simplify this one. We can divide both the top and the bottom by a factor of 5. That will give us 7 over 20. I'll just take that equal sign out here. So our answer will be, I'll just make it look a bit nicer. The answer will be 10 and 7 over 20. Alright, now same deal. Let's pause the video here and have a go at these questions yourself. Just unpause it when you're ready to go through them. Alright, so the first one on the left, we have this number, the tenths, hundredths, and the thousandths. So that it is read as 407 thousandths. So our fraction will look like 407 over 1000. This top number is a prime number, so it cannot be simplified any further. So that will be our final answer. Fraction will simply be 407 over 1000. This last one here to the right, 7.45 or tenths hundredths, so that's 7 and 45 hundredths. We have 7 and 45 over 100. This one can be simplified by a factor of 5 once again. Both the top and the bottom is divisible by 5. So that gives us 7 and 9 over 20. And that can't be simplified any further, so that will be your final answer. Give yourself a tick if you got these two correct. Alright, so the next thing we need to know, our second success criteria, is how to convert fractions to decimals. So our first point, when the denominator is a power of 10, we can simply change the fraction to a decimal using our knowledge of place value. So it's similar to what we were doing before. We're just using our knowledge of place value to go the other way this time. So we have 37 hundredths here, and that simply is written as 0.37. So this is our easiest way. When the denominator is not a power of 10, however, we can try to find an equivalent fraction whose denominator has a power of 10 and then convert to a decimal. So it's much easier when we have a fraction that is a power of 10. So example to the right, we have 2 over 5 that isn't a power of 10. So we can simply make it an equivalent fraction by multiplying it by 2. That gives us 4 over 10 where the denominator is a power of 10. So now we have 4 tenths and we can just write that as a decimal, which becomes 0.4. However, not all fractions can be made to an equivalent fraction that has a power of 10 in the denominator, like this one down below, 5 over 8. There's no way we can make that make the denominator a power of 10 here. So a method that will always work, this is the most longest one and the hardest one, will be to divide the numerator by the denominator. So here we divided the numerator 5 by 8, and that gave us 0.625. Alright, so let's have a go at converting these following fractions to decimals using these sample questions. Alright, so for the first one we have 17 over 100 this one we can use our first method over here because the denominator is a power of 10. So using our knowledge of place value, that is 17 hundredths, and that can simply be written as 0.17 because that is 10th hundredths, so it's written as 17 hundredths. Now for our next one, we'll use our second technique here. When the denominator is not a power of 10, we can find an equivalent fraction whose denominator does have a power of 10. So we can simply do that by multiplying both the numerator and the denominator by 2. So our new fraction will be 5 and 6 over 10. Now that becomes much easier because that is just 5 and 6 tenths. Remember, the big number in a mixed fraction is simply the number in front of the denominator. So with a 5 and 6 tenths. So that will be our fraction as a decimal. Alright, for the question on the right, this one is going to be a bit harder than the two on the left here because we're going to use method number 3, in which we divide the numerator by the denominator. So in this case, the numerator is 7, so we have 7 on the inside and we're dividing that by 12. Alright, so 12 goes into 7 0 times, and if it is 0, we need to write another 0 here and put a decimal point. 12 goes into 70, let's cross that out and write it like this. 12 goes into 70 5 times, and there's a remainder of 10. There's nothing here, so let's add another 0 because 7.0 is the same as 7.00, and we need more zeros to continue. So we need to write the remainder here, so that becomes 100. So now we need to find out how many times 12 goes into 100. 12 goes into 108 times, that gives you 96, so we have a remainder of 4. Write another 0 and put the 4 there. 12 goes into 40, 3 times. That gives you 36, so it's another remainder of 4. Write that down. And it looks like it's going to keep repeating here. So we'll just stop there. And our answer will be 0.583. Put the dot up the top because that means recurring. That means the same thing as 0.583333 and so on and forever. So our final answer will be this one here, 0.583 recurring there. Alright, now once again pause the video here and have a go at these questions yourself, and just unpause when you want to go through them with me. Alright, so our left one, the most simple one, we're just going to use the place value method number 1 here. So we have 123 over 1000, so that means 123,000. So that's simply just 0.123 because that is tenths, hundredths, and thousandths, which is read as 123 thousandths. Give yourself you got that one correct. Alright, so for this next one, we have 19 3/4. We can use method number 2 for this one, in which we make the denominator a power of 10. Or you could use method number 3, that's up to you, but method number 2 is a bit easier. So for this case, to make that a factor of 10, I would multiply both the denominator and the numerator by 25. That makes the denominator a factor of 100. And 3 times 25 will give you 75. So that simply becomes 19.75 or 19 75 hundredths. Alright, so for this last question, it will be the hardest question on this page. We're going to use method number 3, in which we divide the numerator by the denominator. So we're going to divide 5 by 6 here. So 5 goes in the inside, 6 goes on the outside. 5 divided by 6, 6 does not go into 5, so write a 0, and you have to write a decimal point and put another 0 back there. Now 6 goes into 54. 6 goes into 58 times, sorry, not 4. And that gives you 48, so our remainder is 2. 6 goes into 20 3 times, the remainder of 2. And 6 goes into 20 3 times again, the remainder of 2. And it looks like it will keep on repeating itself here. So our answer will be 0.83. And just write the recurring symbol up the top. Give yourself a tick if you got that one correct as well. Alright, so continuing on with recurring decimals, I just wanted to recap on what they are. Recurring decimals are decimals with the repeated pattern. So a dots, or a bar above a number or numbers indicates a repeated pattern. So I've got a couple examples down here. We have 0.3333 constantly recurring. That's just symbolized by the dot on top of the 3 here. Also in this case, we have 1.181818. We have 2 numbers recurring this time, so we can either use 2 dots like that or use 1 bar going over both the numbers that are recurring. The last one down here, we have something longer that's recurring. It's a much longer pattern. So we put the dot on top of the start and the end of the pattern, or we can put a bar across the whole pattern there. So that just means it will be 1.74285, 7142285, constantly going on and on. Alright, so that brings us to the end of our lesson once again. Thank you for watching, and hopefully by now you guys can all convert decimals to fractions, can convert fractions to decimals, and finally be able to understand the different symbols we use to indicate recurring decimals. Thank you for watching, and I'll see you guys all back online.
Boom! 2 + 2 is 4, -1, that's 3, quick maths.